All right, guys, our last set of notes for Unit 4A with our similar triangles. We're going to talk about triangle proportionality theorem as well as indirect measurement. Hopefully, this will go pretty quickly. We're going to start looking at triangles. Like I know with my class, we talked about a little triangle inside of a big triangle. It's kind of what these pictures are going to look like with the triangle proportionality theorem. What's happening though is you're going to have a segment that's going to be drawn inside the triangle that's parallel to a side. So here's segment LW. We don't know, it's not halfway, it's not a mid-segment, but we do know it's going to be parallel to segment or side TS. So we're going to look at corresponding parts here. The first thing that I want you guys to see here is that if we're going to compare RW right here, okay, to down here WS, I want you guys to see where that is located. So you got the one portion and the other portion of the side. This will be equal to RL right here over the little portion of LT. You can either write it there or write it right here. Okay. That's where you're going to see this most of the time in this class this year. But you can also write it as a part versus the whole. Meaning here we're saying RW, so right here, compared to RS, the entire thing. If we do it that way, we look at the other one, the RT is going to be the whole thing. We're going to want the same portion right here that corresponds with RW, which would be RL. So the RL will go with RT. And if this is a little confusing, don't worry about it, because trust me, when I show you the example problems, it's all going to be amazing. We'll do the exact same thing down here, looking at from T to A, so for this area right here, is going to be to R to A, right here, as TI will be to OI. And then same thing with the part versus the whole. We're going to have TA, this little section right here, is to TR, the entire side. Over here, the entire side of TA, so we want the entire side here. We'll put, nope, we want the little part here. It gives us the entire. We want the little part here of IT, or TI, will be to the big part. Again, I know I kind of fumbled with that, but trust me, what's in red right now is what we're going to be using, okay? And that's going to be the easiest way for you guys to learn this. So let's take a look at our examples here. I want you to understand right now that, especially with example number 5 and 7, your proportional setup is staring at you directly in your face right now, and I want you to see how. We have 8 to 6 is to x to 15. So all we have to do is, remember, our proportional setup is a fraction bar equal fraction bar. We fill out the 4 spots. So look, fraction bar equals fraction bar. So all our proportion is 8 over 6, right here, is equal to x over 15. See how nice and easy that is? It's set right there for you. I am going to simplify my 8 over 6 so I can do smaller numbers. So I can take 2 and divide both of these by 2, and it'll give me 4 over 3. So I'm going to use 4 over 3 instead. I'm going to cross multiply here. I'm going to have 3x. And that will be equal to my other cross product, which is now 4 times 15, which is going to give me 60. And all I do, divide. I know this one I'm not pausing because this one's just really, really quick, simple, basic, multiply, divide. And x is going to equal 20. Now in example 6, we are not given each one of the little parts. But over here we're given this whole. Rather than figuring out this whole right here, why don't we just figure out this little part right here? All we have to do is take the entire thing of 30, subtract this 9, and we're going to wind up with 21. So this right here will just be 21. And now we have our proportion. Fraction bar equals fraction bar. We're going to have x plus 6 over x equal to 21 over 9. And you could choose to simplify. 3 will go into both 21 and 9. So I'm going to simplify this down to 3 will go into 21 7 times. 3 will go into 9 3. That way I'm just using smaller numbers, okay? Cross multiply here, we're going to get 7x. That will be equal to, we cross multiply here, we now have the 3. So remembering that that 3 needs to go on the outside of parentheses, and the x plus 6 needs to go on the inside. And I'll work this one through with you. The other ones I will be pausing. So the 7x, we're just going to keep as 7x. We need to distribute. 3 times x gives you 3x. And then your 3 times a positive 6, it's going to give you a positive 18. We have variables on both sides. So let's go ahead and get rid of the smaller one. Subtract that 3x from both sides. We get a 4x equals 18. This will come out to a decimal. Divide by 4. X is going to come out to 4.5. And I encourage you to go ahead and do number 7, 8 on your own. It is exactly like what we just did, just different numbers. So I do encourage you to pause it, try it on your own. I know some of you might, and that's great. I will be pausing in a moment once I have this set up, and I want you to do your cross product and solving. Again, here we have all 4 little parts. So all we have to do is here, fraction bar equals fraction bar. So we have 6 over 4 is equal to 2 plus x over 5. This is where I want you to pause it now. I'm going to pause it, I'm going to work it out, and then resume so you can see your work, but you should be pausing it now. So at this time, you should have your work already worked out for you, and then here is your work. You should have gotten 5.5. All right, on to the next one over here. Again, this one's just like number 6, where we have the 2 parts over here, but we have the whole on the right-hand side. So all we have to do here is take that 42, subtract the 16 at the bottom to figure out what's going to be at the top, and we're going to find out that we're going to get 26. So up here will be 26. So again, here we have fraction bar equals fraction bar. We wind up with x plus 5 over x is equal to, on the right-hand side, we have a 26 over 16. I'm going to go ahead and simplify this 26 over 16. I can go 2 into both of them. This will become 13 over 8. Whether you simplify or not, you should get the same answer. You're going to go ahead and pause it now. As I pause, work it out, and in a moment, your work is going to pop up. And well, you can actually already see it on my thumb. We should have gotten 8, and there is your work for it. Double check your work if you did not get 8. Pause and double check that. Just going to look at the last page here. The last page here. We are going to talk about something that involves using properties of similar triangles to measure heights, lengths, or distances. Sorry, grab my highlighter. That are too great to measure directly. So we're looking here, we're going to measure heights, lengths, distances that are too great to be measured directly. You can also use this for things that are too small to measure. A lot of times it's two things that are too big. This is what we call indirect measurement. It's indirect because we are not taking a ruler or a yardstick and we're not right there exactly directly measuring it. We're going to use proportions. So the first example that we have here walks you through these steps. We have a scale of map of downtown Dallas as 1.5 centimeters to 300 meters, meaning that for every 1.5 centimeters, it's actually in real life going to be 300 meters. So when we're looking at the let's continue. The distance between Union Station and Dallas Public Library is 6 centimeters. What is the actual distance? So what we want to look here is we're looking at 6 centimeters. So we're going to need this one to go in the same spot of our proportion as the centimeters in our ratio up here. So up here, I want you guys to underline this, and I want you to write the ratio. I want you to write ratio above it because we have that colon between. So the first step here says first write the units for the ratio. So what that means is we have our ratios centimeters to meters. So we have centimeters on top, and we're going to have meters on bottom. All right, does everybody understand that one? I'm asking you like you can respond to me. Second, we want to draw a picture if needed, and then also set up our proportion. I don't really feel we need a picture here. We're going to draw a picture on the next problem, but set up a proportion. The first thing we're going to do here is set up the first ratio of the centimeters to the meters. So we have 1.5 centimeters on top, and we have the 300 meters on bottom. Remember that our centimeters are on top, meters are on bottom. They told us the distance in centimeters, 6 in centimeters. That means the 6 needs to go on top. The actual distance is going to be the meters, so that's going to be the x here. So now you have your proportion, and I want you to go ahead and take this proportion. Again, I'm going to pause it. I want you to do your cross multiply. If you'd like to rewrite it, that is perfectly fine. Do your cross product and solve for x. The work is about to pop up, so please pause it. So when we're looking at actual meters, the 6 centimeters will convert to your 1,200 meters. Okay, there's your work. Now the next problem, we're going to have a few different things to take care of here. Okay, generally you do not have to convert from feet to inches, but if you notice in here we have a flagpole cast a shadow that is 50 feet long. So here we've got right here we have 50 feet of the shadow. At the same time, a woman standing nearby over here is going to be 5 feet 4 inches tall. She casts a 40-inch shadow. We want to know how tall the flagpole is to the nearest foot. Well, we have inches and we have meters here. So, inches and feet. So what I'm going to do is we're going to convert everything into inches, and then the end we'll convert it back into feet. So we're going to do this little by little here. All right. So the first thing we'll do is we're going to talk about the woman. Okay? To convert, it's just proportions. Let's say we have feet over inches. We're going to set up our proportion. We know that there is 1 foot, there are going to be 12 inches. Well, let's take a look at the lady here. Now, we know that the lady is 5 feet 4 inches tall. So we need to put the 5 feet here. Question, how many inches is that? Then we'll add the additional 4 inches after we figure out how many inches are in 5 feet. Okay? So I'll just go ahead and work this one out. We just got a single x here, and then we're going to multiply that 12 times the 5, and we're going to find out that x is going to be 60. Remembering that we need to add on that additional 4 inches right here, so we can get her height in inches. And we find out that she is 64 inches. So we'll put 64 right here. I'm doing this purposely so I can show you how your proportion will still be staring at you. Okay? The shadow is 40 inches long, so her shadow right here is 40. Now the flagpole its shadow is 50 feet long. So what we need to do is we now need to do the same thing we did over here with the woman's conversion, and we need to take the flagpole and convert it. So we have feet to inches, and again 1 foot is 12 inches. We were told the shadow was 50 feet, so we're going to put that here. And then how many inches? Again, I'm just going to do an x cross product here. 1 times x, you're just going to get x. And then your 50 times 12 is going to give you 600. So then we're going to take that 600. It is the shadow of the flagpole. Here's the shadow. So that 600 is going to go right here. We want to know how tall is the flagpole. Again, we're going to convert it to feet here in a little bit. So we're looking for right here, the flagpole. So what you see here, whenever I have shadows and buildings and stuff like that, you have 2 little L's here. Okay, and that's how I draw them. They don't have pictures. Again, you have your proportion staring right at you. Watch this. The 64 and the 40, there's your first ratio. We're going to set that equal to the x over 60. So in turn, what we're going to have is that 64, we're going to put here, I'll put my little legend, my little key, we're going to put height over shadow. So the height of the girl was 64, her shadow was 40, and that will be equal to, over here, x over 600. And the legend, the key over here is not too important. It's especially if you have like this drawn out, like these little L's, and that'll help you with your assignment as well. So I want you guys to go ahead. I'm going to pause it, do your cross multiplying, cross product, and figure out what X is. And then here is your work. We should have come up with 960 inches. Now remember, this is inches. We want feet. So now we're going to have to go back and convert again. So this will be our last conversion here. Again, with our feet over inches. 1 foot per 12 inches. Now we have 960 inches. That one goes on bottom here, different than earlier. X is going to go on top. So again, I'm going to pause it. You're going to pause it. Work that out. It is about to pause, and the work is about to pop up, so please pause. So we should have our answer by now, because you paused it, and then once you resumed it, you've got your answer. We should have gotten 80 feet total, and there is the work. So again, with your indirect measurement, even if you're not given this picture, just draw an L, like I did here, for height, shadow, height, shadow. That's the easiest way to do that. Hopefully this helps.